Hello, welcome everyone back again to the Education Diary, day number 2 for the digital forensics. So today we are going to be having some of the very great practicals and some of the very basic, we can say, informations about the digital forensics. Yesterday we have discussed about, as usual, some of the important concepts about the forensics and security and cybersecurity. We have also checked on the theoretical portions, what are some of the countermeasures you can take, what are some of the prevent steps you can take, and what are some going to be that future career which you can actually go on in the field of forensics. Now apart from that, today as usual we discussed that we are going to be using some OpenCV features, libraries to detect and of course a person inside a video or inside that photo. Now I am using the Google Colab, but still that's totally up to you. If you want to use some local software, local IDE like PyCharm, you can go with that. But especially in the case of face recognition, like this library is a huge library, and in the PyCharm this library is not available. Now the important thing is that when you are going to be working in PyCharm and we are going to install by using this command into the terminal, so it's not going to be working there because we are having only 3 libraries in the PyCharm with the name face recognition models, face recognition utils, and face swap or face replace. So we are going to be having these three libraries in PyCharm, but if you are going to be installing this particular face recognition library, so it's going to be really hard. And the important thing is that it is going to give you some error for the dutils or the d-link library. For that we can actually go for terminal, and we are going to be having the command with the name brew install cmake. Now when you're going to be having this command, so this should actually resolve your problem inside the PyCharm, but it's my suggestion not to use PyCharm because overall it's going to be taking the GPU resources. So on the Google Colab you can see that I am using the T4, which is the GPU, not the CPU. So this particular library takes the power of the GPU. So make sure to select your this free version in the Google Colab with the name T4, which is of course giving you the GPU power. Now you can actually upgrade, and of course you can go with the more and more options if you want, but this is the best case and you can actually work with this particular GPU. Right now the very first command you need to work is the pip install face recognition. I've basically done this a few minutes back so that it's going to be really fast for you guys to understand, because we are not doing programming, we are not learning Python. What's my main purpose is to show you some practicals, how the things can actually work and what is the logic behind that. All right, so the very first thing is going to be having the pip install face recognition. You have to run this command, so it is going to be installing the library into your Google Colab. Once you're having the library, so I've taken some of the videos here of President Obama, but that's totally up to you if you want to take any of the other videos or any of the other photos in order to train the model. Now the face recognition library itself is a very great library which is having pre-default some of the models implemented. So it is basically using the CNN networks to find the we can say data points on the face structure. So itself, like if you don't want to train a model, you can use this library face recognition. But if you want to have a customized model, if you want to make a model by yourself, if you want to have that certain photographs of yours or of your friends, and based on those photos if you want to create a model, you have to use some of your own techniques. Of course it can be CNN, it can be YOLO, in order to train the model. All right, so yep, that is basically the basic stuff, but I am going to be using the face recognition library by default today because it's going to be fast, it's going to be easy to implement, and it's not going to be taking a lot of time. But if you're going to be training a model and if you're not having a very great GPU, so it is going to be taking a lot of time in order to train your model. So that's why I'm going to be directly with the face recognition library for you guys to understand that what is the approach. Once actually you have implemented this particular command, it is going to be successfully installing into your Google Colab. Make sure to have the image, the source image. Like suppose if I want to recognize one of my friend's face inside that video or in a group of videos or in a group of photo, so I can basically have his photo or her photo here in the Google Colab. And of course make sure to have some videos. It can be any videos inside which your friend is there, right? So you can take multiple videos if you want. So this is basically, we are using CV2 library, which is OpenCV. We are using face recognitions. We are going to be taking IPython display, which is going to be taking and going to be displaying the number of frames in that video. And PIL is of course going to be making the images into the frames. It's going to create a box around the face inside that frame. So overall, we are going to be having 3 modules or 4 modules which are going to be working in this particular function. But yeah, you can go more and more at once. And accordingly you can create more and more complex things as well, right? So here basically I gave the path of the source person. It can be your friend as usual, right? Here you are going to be giving the path of your video, whatever video you want to have. By the way, you can also go with the real-time video recognition, which is of course in the part of CCTV. But we are going to be going through the video directly, right? So this is actually the code, which is just I have created here. Once I'm going to be running in the code, so you are going to be having the display here of a person. So this is actually, you can see that this video is working frame by frame. All right, so the video is actually working frame by frame, and the model is basically recognizing, or the face recognition library is basically recognizing Barack Obama inside that particular frame, right? So this is one of a very great technique. Now the drawback of the technique, or the drawback of using a pre-default library, is something which is very clear, which is going to be having low F1 score, low accuracy, low precision, low recalls, and of course we are not going to be having a very high precisions inside these things. It's really important to understand. Now here in this frame, you can see that as soon as the Barack Obama's face has been inside, or we can take a side view, so there is no recognition on his face. That means by using a pre-default library, which is a face recognition, so there might be some chances of having some errors. So yeah, by using these kind of we can say flaws or vulnerabilities, a criminal or any person whom actually the CCTV wants to find can that flee from that place. So we have to train our own customized model. We have to increase, we have to give more and more data set to that model. Right now here you can see that I'm just taking one image source, which is the obama.jpg. But if I'm going to be having tons and tons of photos of Obama from different angles, from up, down, right, left, it can be diagonal, right, from certain frames, from certain angles, when I'm going to be uploading the data set of Obama, so the model is going to be working much more greatly, so that even if the person is having any side view, so still the model can work perfectly, right? So this is one of a very great technique through which you can work on, but this is just a demonstration so that you can understand that how digital forensics actually work, and how actually the CCTVs can actually recognize a face in the public or any kind of like that. All right, so let's stop this one. And what basically I told you is something which is pretty important to understand, that the pre-default library, which is a face recognition library, doesn't work properly. And how can we say that with having the low F1 score, low accuracy, low precisions, and low recalls? If I'm going to be taking another video of the Obama, which is from the very side view, so this is one of a video in which the Obama is basically in the public and having a very side view, and there are lots of people. So in this, actually you can see that even though we are having the face recognition library being implemented, still it is not able to recognize the person, which is the Obama. Now there can be various uncertain factors like the reflections, lights, brightness, contrast, bandwidth, and of course the pixels values. But still, this is something which is clear, that by using the pre-default libraries like face recognition is something which is not reliable in the field of forensics. But it also gives you a general idea that yes, it's much more better to train your own model, having some own data sets, and then by using those data sets you're going to be having much more better program in order to run these kind of things. All right, so I think so, like, you just get an idea that what we have done, right? It's not very difficult to understand, and in the same you can actually import some of the images, right? So suppose if I am imported Obama and Biden, then basically I can train the model on Biden, and I'm going to be having any video of Biden, so it is going to be reflecting there, right? So you just get an idea that yeah, it's kind of like a really good project to go on face recognition. Now in this face recognition models, you're going to be having more and more advanced projects which you can do, like suppose in front of a like screen you come, in front of a computer you come, so as soon as the computer recognizes you, it turns on or it displays any kind of message. And suppose if someone else tries to come in front of a screen or in front of a computer, so the computer actually denies the kind of access and it shows a different message. So as soon as I come in the front of computer, it can actually redirect me to a website where I want to go. It can be my attendance website, or it can be my business website, or a portfolio. Like it's just like an idea, right? And suppose if any person comes in front of the computer, so it basically denies, or it basically says that the access is denied, something like that. All right, so this is just an overall view of the forensics in the field of forensics, that how can I actually recognize someone inside a video, inside a frame, inside a JPG. Now the problem with all these things is that it's really hard to go frame by frame. So the software, so the today new modern day softwares actually skip some of the frames which are of no use. All right, so suppose if there is a video which is a 15 minutes or a 1 hour long video, so if there is a criminal inside that video, but in some certain frames, not in all the frames, so the softwares are having a really great capability that they can actually delete the frames in which there is no motion or there is no person in that frame. All right, so it basically reduces the time, reduces the effort, and only provides us the frames which are really important to consider and to check for that criminal. All right, so this is just a general view. Now apart from that, the another forensic tools, now there are tons and tons of forensic tools which you can search on. It can be autopsy, it can be KMCG, it can be GMD softwares, or it can be more and more. We can use even these softwares in the Linux. So Linux is one of a very great source of working with the recovering things. Now we are not going to the Linux because in the future lectures, when we are going to be working on some ethical hacking, on some cyber security stuff, so we are going to be trying to include how can we recover the deleted photos or videos from a 2-year or 3-year-old SD card or a mobile phone, or from the memory card or something like that, right? So we do have some really great and really free open source softwares in Linux, but in Windows or Mac it's pretty hard because they are at least paid, right? So yeah, as usual, we do have a very basic introduction about the Wireshark some days back when we were having the Ubuntu system. We were having some introduction to Ubuntu, introduction to Linux. We do had discussed about some really great stuffs in Wireshark. Now here the Wireshark is basically a packet analyzer or a network analyzer software. It basically analyzes every request your computer is sending and receiving from the server or from the internet. It can be any request, even if you write www.google.com, so as soon as you hit enter, so the request is actually sent to the server and it basically returns back to your computer from that server, which is ultimately known as the source and the destination. All right, so here you can see that one interface is down, 28 is hidden. So suppose if I go with the wired, now we are going to be having tons and tons of different, we can say, interfaces. Now what actually the interfaces tells you is that we are using Wi-Fi, and here you can see that it is having a lot of signal, and as usual I am using a Wi-Fi. All right, apart from that, if you are going to be having Ubuntu, so it's going to be showing you Ubuntu 1, Ubuntu 2, Ubuntu 3, Ubuntu 5, and so on, bridge. Now these are actually some of the external, we can say, network ports which our virtual machines are using, right? By the way, I am not using right now any virtual machine like Ubuntu or Windows. Still it is going to be displayed here because yes, these are the part of the system, but these are not very important because we are not looking on these. But here actually you can see that this is the address. The IPv6 addresses are being given here, right? In the Wi-Fi, if you go, you are having the IPv4 as well as IPv6 address, right? So suppose if I click on the Wi-Fi, And here, by the way, by default actually it is already running, because somewhere my Google Colab or any other resources are sending a tons and tons of requests from my computer. Of course, I am streaming right now, right? So actually I forgot that I am streaming from my main operating system via YouTube. So here you can see that from my system the requests are being going to the YouTube server, and from the YouTube server actually I am getting back the request or the responses. All right, I'm going to be stopping the network capturing here, because by the way you can start your network capture here from clicking on this blue button. But if you want to stop the network capture, so you can actually press on the red button. Now there are tons and tons of features in this. If you go, you're having some analyze menu. From here you can actually analyze the packets, you can actually have some statistics, you can create some graph, you can have some visualization to show that how the things actually work. Let's go and have some flowchart or the flow graph, if it can create. I'm not sure, but yeah, here actually you can see that it basically created a flow graph, that what is something the ACK, or kind of like the request sending and request receiving. So yeah, you can basically check out the IP addresses here. Now the IPs are hopping because as usual I am using OBS Studio, and the OBS Studio is of course linked with a stream key, and that stream key is basically being connected with a YouTube stream. All right, so we are going to be having 3 or 4 steps from by which my computer is basically getting the responses, or the server is getting response from my computer. All right, apart from that, basically you are going to be having this as an source IP address, and at the very last you are going to be having the destination IP address, which is this one. So we can say that yes, this is the destination IP address, and this is the source IP address. All right, now we do have some many other IPs, but we are not having the reachability to that particular position. Yeah, so that is something. So here you are having tons and tons of different options you can go with. Suppose if I just want to check for TCP protocols being implemented, not the other protocols, so I can actually select only for the TCP. Now as usual, I told you that going into the Wireshark basically takes a really lot of time, right? So this tool, this software basically takes around 3 or 4 months to understand, to work on, because of the availability of so many options, right? So as usual, it's going to be only showing us the TCP protocols which are being used inside that particular packet, and then we can go for the more and more protocols like the UI and flows. So yeah, there is no UI and flows right now. We can go for the ICMP if there is any protocol, if there is any IP which is taking ICMP. All right, so there is nothing. So yeah, this is the overall view of the Wireshark for the basic, of course. Now the important thing which you need to consider is this tool is really good in the field of forensics if you want to study the network packet, because nowadays if you are sending a message to someone, suppose let's take an example of WhatsApp, you're sending a message on WhatsApp to someone, it is basically encrypted, right? So it is two-side encrypted, and as usual it's really hard to check out what is the actually message a person has sent. But as soon there is one hacker in between these network, and he basically captures your packet, so he can actually try to read your packet, right? So that is the basically part of the forensics. But of course in the way of we can say legal, or we can say in the field of jurisdiction, or in the field of cybersecurity, so basically these packets are being used to study about some malicious messages or some harmful messages, some violent messages or whatever, right? So suppose if I go here and I click on this particular packet, so as soon as I click on this particular packet, you are going to be having some string values, some hexadecimal values, which actually is kind of showing us that it is basically encrypted, right? But there are going to be some certain tools which we can use to decrypt the messages inside that particular packet. Now this is going to be showing you that this packet is basically 146 bytes, that around 1 KB, right? So this packet is of only 1 KB, and there are going to be 52,580 frames in this 1 KB of packet. Now these frames are actually telling you that in how many divisions this packet has been distributed and then sent over the network or over the internet. Now the epoch arrival time is basically this much, right? UTC arrival time is April 21, blah blah blah, and so on, right? So it basically shows you some of the very important details, like about how the packet is actually behaving. If the packet is having more value, suppose if the packet is going to be having a lot of values. Like it's going to be having, suppose if the packet is of around 3 MB, 10 MB. So by that we can actually study that yeah, there is some image which has been sent or which has been received, or it's a video which has been sent or received, because we can study the frames inside that particular packet. All right, now this is something as usual Ethernet 2. We are using Apple device, we are having connected with the Ethernet. So this is something which is just telling us about the packet which is being sent from my computer, right? Now internet protocol, as usual, we are going to be using some TCP. Source address is my computer, destination address is a YouTube, right? We are going to be having some services. Now you can actually study, right? But as usual, I told you that it's going to be very hard to study all these things, because it's going to be taking a lot of time. All right, so the source port is basically this one, destination port is 443, which is the HTTPS, and source port is 63,017. So overall we have 65,535 ports overall inside the field of networking. So my source port from this computer is this one. Now I'm not sure what is the name of this port, but 443 is basically HTTPS. The port number 80 is HTTP. The port number for SSH is 22. And for the port or number TCP is going to be, I'm not sure about TCP, yeah, 21 is going to be the TCP port number, right? So it's really important to learn some of the really important port numbers. It's not really hard, but at least yes, like you should know some SMTP. You should know about some UDP port numbers, HTTP, HTTPS, SSH, and DNS, DHCP, right? So these are some of the really important services and their port numbers, which are really great to learn, right? Now here you can see that there is something Windows Server, right? So actually my computer is sending a request. In order to receive that request, the Windows Server is working somewhere. There are some flags. You can actually, that expand these flags. Now as usual, these are not some really important things to consider here. But yeah, the TCP segment data is 1400 bytes, around 1 KB. Now this is something, a form of message, which can actually show you that yes, character 97 6FE4 actually tells us about the letter O, and we are going to be having AA2E6798 as G. Now this is something really important to understand, that yeah, whenever there is an encrypted message, what the encrypted message means, how can we decrypt that. It's really hard to decrypt all these things over the network of HTTPS, but if we are working on only HTTP, so it's really easy to gain some password, some username really easily. All right, now there are some certain attacks which we can do to make any HTTPS website into HTTP, and then we can tell any of the user to go to that website and they can actually sign up or log in, and in the meantime we can get their ID and passwords. All right, let's go back, let's close this packet, because we studied this packet, right? So the packet is around 500 and I'm not sure, so the packet number is 52580. Now within only 30 or 45 seconds you are going to be having like hundreds and thousands of packets, right? Let's try to read the packets which are of this black color. So suppose if I click on this, now here you can see that there is a very less hexadecimal values and there are very less encrypted text, right? So suppose if I expand this, so again you can see that this is having a really less values, and it is not even showing me that what is the size. It is only of 66 bytes, right? So this packet was actually, we can say, destructed in the way when it was traveling to the internet. That means it is not a complete packet. All right, so this usually happens that when you are loading any website, so of course there is some milliseconds or really nanoseconds of time when the request is unable to get, right? So suppose if I search google.com, it is going to take around 1 second or 2 seconds to load, but in order to load that website, the really millisecond or the nanoseconds of time which are taking, there might be some packets which crashed, which destructed on the way when they are going to the server. So yes, this packet is actually really small size, so we can say that yes, this packet was being crashed somewhere when it was being sending to the server. Right now this is only 520 or 66 bytes, but of course 528 bits is being captured on the interface which we are using Wi-Fi, right? And encapsulation type is Ethernet. Of course we are using Wi-Fi, and the Ethernet is basically an encapsulation. Now what is encapsulation? If you know about programming, so you know about this term encapsulation. In cybersecurity, encapsulation means the tunnel of the packet has been destroyed. Now there are some frames. Now here frame is marked is basically false. That means there was no frame which was being recognized by the Wireshark because the packet was corrupted. All right. Once again, as usual, I told you that yes, this is just a way of studying any packet. All right. So suppose if you're sitting in a home and two of the persons are connected on the same Wi-Fi network like you, so you can actually read what they are sending, what the request they are sending, and what the request or what are the responses they are receiving. So at the last, this is something the part of the forensics. That means we can study the networks, we can make some programs in order to recognize the people inside that video. We can create some of the programs which can use some audio libraries to recognize the audio or the voice of that person, right? We can create some programs or we can use some softwares in order to extract information from any of the lost device, or we can actually recover some of the lost or the deleted things around 2 or 3 years back, right? So overall we are going to be having lots and lots of fields in the field of this digital forensics. That's totally up to you how you approach, in which field you can approach, but my suggestion is at least have some very basic knowledge in every field. All right, in the Linux also you should be having at least some knowledge in the field of tools or softwares using. You should have some knowledge in the field of programming, you should have some knowledge. So if you're going to be having knowledge in multiple fields, so it's really easy for you to understand or work on that and know or gain more knowledge on that field. Having only knowledge in one specific field, like suppose in OpenCV or in the field of recognition, it's going to be really hard, because at the last of the day the only person who knows more is having more capability or chances in getting a job, especially in nowadays in with the pricing of AI. All right, so this is going to be my personal suggestion to know all the things. It can be softwares, it can be Linux, it can be Windows, it can be Ubuntu, it can be that anything in the field of IT. If you have multiple knowledge, so it's really really great. All right, so if you are going to be having any questions or doubts, make sure to send email to the education diary. If you are going to be having some questions or doubts regarding this particular webinar, make sure to comment down on the live stream, and we are going to be trying to give you the reply as soon as possible. Thanks a lot and have a nice day everyone ahead.